This is 4.1 notes. So 4.1 deals with transformations of graphs and symmetry, meaning we take one of these base functions and we shift it. Okay, so we're going to take some function like y equals x squared, a parabola, or the absolute value function, or cubic function, square root function, one of our base functions, and we're going to move them around in the plane. Alright, so what this is telling us right here, horizontal shifts of the graph. H is a positive real number. Alright, it's important that we see that it says positive right here. The graph of g of x equals f of x minus h can be obtained by shifting the graph of the original h units to the right. So for instance, if g of x equals x minus 4 squared, what this is saying is this is the same as the graph of just plain old y equals x squared, but shifted to the right 4 units. Alright, so that's what that top one is telling us. Okay, if we subtract some positive number, then we end up going to the right. Alright, so subtraction goes to the right by h units. Now, if we take some positive number and add it to inside the parentheses, then that shifts the graph to the left, the opposite way. So if I did x plus 8 squared, that's the same as y equals x squared, but this time it's shifted 8 units left instead of right. So this time it's going to shift it to the left. Okay. Now, this time we have k. K is a positive real number. If we have f of x, notice this time that the addition and subtraction are taking place outside of the parentheses, not inside like it was up here. So outside of the parentheses, we take the original graph and we shift it up k units if this is positive. And if we subtract k, then we shift the graph down k units. Okay, so that means if g of x were x squared minus 4, that's the same as just plain old y equals x squared, but this time shifted down 4 units. Alright, and then if we added 4, or added 8, I meant to do 8, that's the same as y equals x squared shifted up 8 units. Alright, and then on this next slide that I have, this kind of just summarizes what we just said. So this is the base function. Okay, the base function is just x squared. Notice the vertex here is at 0, 0. Alright, the vertex meaning that point where it changes direction. Alright, well, what does this do? According to what we just said above, this shifts it 4 units to the right. So there's 1, 2, 3, 4 on the x-axis. So now the vertex is 4, 0. Okay, because it's been shifted to the right. Alright, and then if we look at this one, This is x plus 6 squared. So because of the plus, that's going to shift it to the left. This shifts it to the right. And then there's 1, 2, 3, 4, 5. This is negative 6. Okay, so now the vertex is negative 6, 0. Alright, so that means it shifted left 6 units. Alright, but it's, if you look at them, you can kind of see it's just the same graph as we had up here. This U-shaped parabola is just being moved around, left and to the right. Alright, and then likewise, this is that same graph. We added 5, so that made it go up 5 units. Okay, and then here we subtracted 7, so the subtraction made it go down 7 units. But again, it's just that same parabola. It kind of looks different here because we're seeing more of it on this one and less of it here, but it actually is just that same parabola. That vertex is just being shifted around. Alright, so the vertex here again is at the origin. Alright, we didn't shift left or right, but this time we shifted up 5 units, so that vertex is 0, 5, 1, 2, 3, 4, 5. Alright, and then here we went down 1, 2, 3, 4, 5, 6, 7. So we're down here at negative 7. The vertex is 0, negative 7. Alright, so you can plot these on your own calculator and verify. Plug in any numbers you want. In a parentheses is going to shift it left and right. Out of the parentheses is going to shift it up and down. Alright, and then just to make absolute sure of it, let me switch this. To make absolute sure of it, we're going to show one that has a little bit of both. So what I got here, this is the absolute value of x, the one in red here. So that's this V-shaped graph. Alright, right here. Alright, and what does this say to do? This says to shift it to the right 6 units. Alright, because it's minus 6 inside the parentheses. And then this says to shift it up 3 units. Alright, so right 6, up 3. Now if I take any of these points that are on this graph, like for instance negative 2, positive 2 is a point on this graph. Alright, if I take negative 2 and positive 2, which is on, again, it's on this graph because the absolute value of negative 2 is positive 2. If I take that point and shift it to the right 6 units, who is that? That's the x-coordinate. Right? If the x-coordinate is shifted right 6 units, we add 6 to that. Negative 2 plus 6. Right, and then we shift it up 3. That's the y-coordinate. So we take that y-coordinate, add 3 to it. And what do we end up with? We end up with 4, 5. Alright, and then count it over as 1, 2, 3, 4. And then go up 1, 2, 3, 4, 5. There's that new point. It was shifted over 6, up 3. And every point that's on this graph is shifted over 6, up 3. The vertex, or the origin here, shifted over 6, up 3. So from 0, 0 to 6, 3. Okay? So all these points are on this graph. This new graph by shifting over to the right 6 and up 3. Alright, so that was right 6, up 3. Okay? Now here's a cubic down below, meaning y equals x cubed. That's going to be this one. Alright, it bends in towards the origin and then it comes back down. Alright, that's y equals x cubed. And then the other one is y equals x plus 5 cubed minus 4. Alright, so we added 5 in the parentheses. What does that do to the graph? that shifts it to the left 5 units. Alright, and then what does this do? This shifts it down 4 units. Okay, so the origin's on there again. If I go left 5, 1, 2, 3, 4, 5, down 4, 1, 2, 3, 4. There's where that origin ends up. Alright, and notice origin is where it's bending and turning around to go down. Same exact location, it's just moved to left 5, down 4. Okay, so that goes left 5 units and then down 4 units to get the new graph. Alright, now stretching and compressing, it's the same idea as before. We take this base function, and what this is saying is if we multiply original function by some number, then we get a stretch of the graph by some factor if it's greater than 1, and we compress the graph if it's between 0 and 1. So what this is saying is, if I have plain old, there's my base function again, x squared. If I just take that function and multiply it by 5, it's like I'm putting a nail in the vertex. So there's my nail, and I'm grabbing hold of the ends and I'm pulling them upward. So there's my hands pulling the graph upward. So it's a vertical stretch of this original graph. Alright, so the y values are higher than they used to be by a factor of 5. So that's what this is saying. The graph is vertically stretched by a factor of, in this case, a is acting like 5. Okay. Now, in this one, 1/10, that fits in down here between 0 and 1. The number out in front is a 10th. What is it doing? It's vertically compressing the graph by a factor of a 10th. So this time, there's our nail again. If you want to say that we're putting it in the vertex, that's what doesn't change when we multiply. The output doesn't change when we multiply it by the number. And this time, I'm taking the graph with my hand and I'm pressing it downward. I'm compressing it vertically, meaning I'm pushing it down towards the x-axis. Okay, so that's what we mean by vertical stretch or compression, but really it's just whatever number you're multiplying it by. If that number is bigger than 1, then it pulls it up vertically. If it's between 0 and 1, it pulls it down towards the x-axis vertically. Alright, now this one, reflections, the best function to use for reflections is a square root function because it's just exists in the first quadrant. And what this is saying is, if we multiply the output, not in the parentheses, but outside the parentheses, this one's outside the parentheses, we go over the x-axis. So notice here there's no negation going on inside the parentheses. This is outside. Alright, and what does it do? It flips the graph over the x-axis. Alright, and we end up down here. Okay, now this is inside the parentheses. Alright, notice that that negation is on the inside, and which ones it go across? This time the y-axis. Alright, so here we've got that negation going on inside the parentheses, and now it goes across the y-axis. Alright, so reflections occur with the negative signs. Just where is that negative sign located? If it's outside, it's across the x-axis. If it's inside, it's across the y-axis.